Hi, I Aziz welcome you to CoedMaster, and in this video I am going to solve a problem. And the problem is given as we are given a number and we have to find number of trailing zeros in factorial of that number. So before we move on, let's understand what is meant by trailing zeros. So the trailing zeros are those zeros which appears after the rightmost non-zero digit. So in this number there are 3 zeros, but the number of zeros appear after rightmost non-digit number are only 2. So in this case there are only 2 trailing zeros. We are not going to count this zero as trailing zero, right? Okay, clear. Now we understood that what is meant by trailing zeros. Now let's pause this video and think about a solution to find number of trailing zeros in factorial of a number. Alright, let's see this solution. So in previous video we saw that how to find the factorial of a number, how to get the last digit of a number, and how to remove the last digit of a number. So in this solution we are using these 3 tricks to get number of trailing zeros in the factorial, right? So what we are doing in this function, we are first initializing a fact variable to 1, and in first loop, in for loop, we are first finding the factorial of a number, and in second loop we are simply counting the number of zeros in that factorial. And we are using the simple trick. First we are doing modulus with 10 to get the last digit, and if it is equal to 0 then we are simply counting the number of 0 and we increment the count by 1, and at the same time we are just removing the last digit of a number. So let's understand this with example. Let's say we have 3628800 as a factorial of 10. So in first iteration we get the last digit by doing modulus with 10, we get 0, the condition becomes true and we get into the loop, and we simply increment the count by 1, and at the same time we are removing the last 0 by dividing this number by 10. So now we have 362880. We do the same thing in the next iteration. Now our number reduces to 36288 only. And in next iteration we again do the same thing, but this time we get last digit as a 10. So our loop gets stopped here and we come out of the loop, and simply we return the count of trailing zeros. So in this case the count of trailing zeros comes out to be 2, because in factorial of 10 the number of trailing zeros are 2. Okay, this is the simple solution to solve this problem, but this problem has major issues. And what is that? Let's see. The issue is this problem causes overflow issue. Why? Because if you pass n is equal to 5 or 10 or 15, then obviously this code is going to work smoothly. But let's say if you are passing n is equal to 100, and the factorial of 100 is going to have 158 digits in total. If you see, the range of integer data type is only 10 digits, and the range of long data type is 19 digits. So anyhow we are not able to store the 158 digits in integer as well as in long. So here in this case our solution is not going to work. If you try to run this code with n equal to 100, it simply throw overflow error. So now what to do? So here we have some observations to make. So first of all, let's see how a number gets trailing 0. A number gets trailing 0 when it is multiplied by 10, right? So if we multiply 10 with 1, we get 1 trailing 0. We get 10, right? If we multiply 1 with 2 tens, we get 2 trailing zeros. See, similarly, if we multiply 10 with 12, we get 1 trailing zeros. So it means that whenever a number gets multiplied by 10, it gets trailing 0. Okay. So now if I want to count how many number of trailing zeros a number has, so I simply have to count number of tens to get the trailing 0, right? And to get the number of tens, we simply have to divide that number by 10. We saw in the previous example, right? And for a number to be divisible by 10, it should be divisible by 2 and 5. Why? Because the prime factor of 10 is 2 and 5. So number must be divisible by 5 and 2, right? So now we have two options. Either we find the number of tens or we can find number of pairs of 2 and 5. Both are same thing. Either you count number of tens or either you count the pair of 2 and 5. Now let's see in our factorial example. So in our case, we do not want to count the factorial of a number, right? Because it causes overflow issues. So we cannot count the number of tens also. But we have one option that we can find the pairs of 2 and 5. And this way we can find that how many trailing zeros are there. So let's see how we can use this idea to solve this problem. So when we do factorial of n, we simply multiply all the numbers from 1 to n. So in case of 10, we are multiplying 1 into 2 into 3 into 4, so on and so forth till 10. Okay. Now our task is to find the number of pair of 2 and 5. And how can we find this? Let's see. So if you observe this factorial of 10, you will see that every second term is contributing 2. Here 2, 4, 6, 8 and 10. All these digits are contributing 2. 2 is contributing 2, 4 is contributing 2 times 2, 6 is contributing 2 one time, 8 is contributing 2 one time, and 10 is also contributing 2 one time. And if you again observe this factorial series, you will find that every fifth term is contributing 5. It means 5 is contributing 5 and 10 is also contributing 5. So in this factorial of 10, the number of 2's are 6 and the number of 5's are 2. Okay. So we can say that the number of 2's are much greater than number of 5's. So do we really need to find the pair of 5 and 2? What if we only count the number of 5's? Because the number of 2's are already greater than 5. So the number of 5's will automatically pair up with all those 2's, right? So our problem boils down to we only need to find the number of 5's. We do not need to count the number of 2's now, because number of 2's are much more than 5, right? So in this example, how many pairs of 5 is possible? There are 2 pairs of 5 is possible. So the number of trailing zeros in factorial of 10 is 2, and that is correct, because if you find the factorial of 10, you exactly get the 2 trailing zeros. Now the question is how to find the number of 2's in any number. So it's simple. If you divide any number by 5 and take the floor of it, you get the number of trailing zeros. It means if we divide 10 by 5, we get 2. It means the factorial of 10 is having 2 trailing zeros. So now the question is it going to work in all the cases? Let's see other cases also. So in case of 15, if we divide 15 by 5, then we get 3. And because the factorial of 15 is having 3 trailing zeros. So in case of 15, the 5 is contributing 1 5, 10 is contributing 1 5, and 15 is contributing 1 5. So far so clear, that's great. In case of 20, if we divide 20 by 5, we get 4. And the factorial of 20 is having 4 trailing zeros. Here 5 is contributing 1 5, 10 is contributing 1 5, 15 is contributing 1 5, and 20 is also contributing 1 5. Great. Now let's move on to next example, that is 25. If we divide 25 by 5, we get 5. But the factorial of 25 is having 6 trailing zeros. So what is happening here? So here 5 is contributing 1 5, 10 is contributing 1 5, 15 is contributing 1 5, 20 is contributing 1 5, but 25 is contributing 2 5's, because 25 is made up of 2 5's. 5 into 5 is equal to 25. So our solution is not working here. So let's see how we can fix it. So if we look at the factorial of 25 closely, we see that every fifth digit is contributing 5. So 5 is contributing 5, 10 is contributing 5, 15 is contributing 5, 20 is contributing 5. But the last digit is contributing 2 5's. So when we divide 25 by 5, we are counting all the 5's, right? But this number has 2 5. So now what to do? So to solve this problem, we simply increment the power of 5 by 1. So it becomes 5 to the power 2, it becomes 25, and we simply count the remaining 5 by dividing 25 by 25. So we get 1. So this way, if we sum 5 and 1, we get 6. So we got our answer. So there are 6 trailing zeros in factorial of 5. Similarly, if we take n is equal to 128, and if we divide 120 by 5, we get 25 5's, and we increment the power of 5 by 1, and next time we divide 128 by 25, so we get remaining 5 5's, okay? And next if we divide 128 by 125, we get the remaining 1 5's, right? So if we sum all the 5's, we get 31, and if you do the factorial of 128, you exactly get 31 trailing zeros. How it is working? Because in 128, every fifth term is contributing 1 5's, correct? So how many 25th term is there in 128? There are 5 25th term, okay? And how many 125th term in 128 there is only 1, because 125 and then it comes 128, so there is only 125th term in 128. So this is how we calculate number of trailing zeros in any factorial. But how can we be sure that our approach is correct? So let me show you some proof. So let's see this with an example. In case of factorial 10, we get some number, and if we write prime factors of that number, we simply get 2 to the power 8 into 3 to the power 4 into 5 to the power 2 into 7, and the highest power of 5 is 2. It means there are 2 trailing zeros in factorial of 10. Similarly, if we count the factorial of 15, we get one number, okay? And if we write the prime factor of that number, it comes out to be 2 to the power 11 into 3 to the power 6 into 5 to the power 3 into 7 to the power 2 into 11 into 13. Here the maximum power of 5 is 3. It means the number of trailing zeros in 15. It means the number of trailing zeros in factorial of 15 is 3. So it means our approach is correct. We are counting 5, right? And in prime factorization of 10 factorial is also we are counting 5. So far so clear. So now let's write the generalized formula to find the number of 5s. So the generalized formula comes out to be, so first divide the n by 5 and take floor of it, and next divide n by next power of 5 and take floor of it, and so on and so forth. And we have to follow this process till the value of denominator is less than equal to n. Now let's see the implementation of this formula. And this is the implementation, and it looks really simple. So what we are doing, basically we are running a loop from 5 till less than equal to n, and in each iteration we are incrementing the power of 5 by 1, and we are simply dividing n by power of 5 and incrementing the count in each iteration. So once the value of I reaches to less than equal to n, the for loop gets terminated and we simply return the value of count. So let's see with an example. Let's say if n is 10, the initial value of count is 0. In first iteration, the value of I is 5. We divide 10 by 5 and we increment the count by 2. In second iteration, the value of I becomes 25, and this is where the condition becomes false and we come out of the loop. So the output of this input is going to be 2. It means the number of trailing zeros in factorial of 10 is 2. Okay, in case of, let's see next example. Let's say if n is equal to 128. The initial value of count is 0. In first iteration, we divide 128 by 5 and the value of count becomes 25. We have seen this before, that when we divide 120 by 5, we get 25. In next iteration, we increment the power of 5 by 1, it becomes 25, and this time the value of count becomes 30, because 25 plus 5 becomes 30. In next iteration, the value of I becomes 125, and if we divide 128 by 125, we get 1. So 30 plus 1 is going to be 31. So the output of this input is 31. It means there are 31 trailing zeros in factorial of 128. Great. So I hope now you have clear understanding about how to find trailing zeros in factorial of any number. And this is it for this video. Thanks for watching. See you in the next video.